All right, because that other logic problem was quite difficult, I thought I'd take you through a simpler version of that type of problem. So this is from the materials I've been doing with my students over the last few weeks. It's dealing with a short story called The Lady or the Tiger by Frank R. Stockton, which is a really great short story. It has an ambiguous ending, so I highly recommend reading that story at some point as well. Anyway, the story deals with a king who chooses to punish people or try people by sending them to an arena where they're faced with two doors that they can choose to open. One door leads to a tiger that will presumably eat the accused, and the other door leads to a lady, a beautiful lady that the accused gets to marry. So he basically has a 50-50 chance of either being punished or being rewarded. All right, so and then this is put in a mathematical context here. So this is the first trial. Suppose both rooms contain tigers, asked the prisoner. What do I do then? That's your hard luck, replied the king. Suppose both rooms contain ladies, asked the prisoner. Then that's your good luck, replied the king. You could have guessed the answer to that. Suppose one room contains a lady and the other a tiger. What happens then? Asked the prisoner. In that case, it makes quite a difference which room you choose, doesn't it? How do I know which room to choose? Asked the prisoner. The king pointed to the signs on the doors of the rooms. So you have the two signs. There's only two rooms and two signs. So this is a much simpler version. Sign 1 above room 1 says, in this room there is a lady, and in the other room there is a tiger. And room 2, the sign says, in one of these rooms there is a lady, and in one of these rooms there is a tiger. Is it true what the signs say? Asked the prisoner. One of them is true, replied the king, but the other one is false. If you were the prisoner, which door would you open? Assuming, of course, that you preferred the lady to the tiger. Right, so yeah, as I said, this one's quite simple. You've only got the two choices. It can be either this one is true, which would mean that this one is false, or the opposite, this one is false, and this one is true. Okay, so a much simpler example, but this is a good way to see that children understand the basic premise of what's going on here. All right, so let's maybe make this one true, just to illustrate. In this room there is a lady, and in the other room there is a tiger. So that means there's a lady in room 1 and a tiger in room 2. In one of these rooms there is a lady, and in one of these rooms there is a tiger. But for the conditions we already established, that would mean that this is also true. So it can't be that, right? So yeah, so we know option 1 can't be true. Option 1 has to be false. Okay, so in this room there is a lady, and so instead we do the opposite. In this room there is a tiger, and in the other room there is a lady, and we go across here, and we can now make this one true because the conditions have still been met. Okay, so which room should he choose? He should choose door number, sorry, because it's false in this room, there is a lady, is false, so it's room 2. You should choose room 2, there's a tiger in room 1 and a lady in room 2. So that would satisfy the conditions of this one being false and this one true. And then we went through a whole heap of different trials where they get progressively harder. But I think this is a good one to illustrate the idea of trying the different combinations.